So lab strategy. What equipment do we have in the lab? That's the first thing. What kind of equipment can we expect, and in what kind of topology can we expect that? So let's start looking at the blueprint. We see that we have a number of devices. First of all, we have a terminal server and a CAT3750 switch. Well, don't be bothered with this because these will be used for management. So the terminal server will be your console lines, and the CAT3750 will be the management switch where all the management 0 ports are connected to. So your machine will have access to these systems, but you will not have access to those systems directly. So don't care about these ones on the blueprint. Then the first most interesting one, the MDS9222i. That is exactly the switch that we are using here in our rack, and that I used in the example of yesterday to do the fiber channel uplinks and all kinds of stuff, and the iSCSI stuff. So the MDS9222i supports, besides 18 ports of fiber channel, 1/2 gigs, or maybe 4 gigs, also 4 times a 1 gig Ethernet connection. So that is where I run my IP features like FCIP and like iSCSI. We will probably have 2 or 4 MDSs, depending a little bit about the topology. But of course the biggest one we start with is the Nexus 7000. It states 1 supervisor, so this can be a SUP 1 or a SUP 2. Well, you can take my word that it will be a SUP 1. Because also related to the software version that they are running on it. They specify the 6.x, so they technically can run the most recent version, but the 602, that's better supported on the SUP 1, so they are running a SUP 1 in the lab. They're running a 7009, but we don't care about that for the lab, because we only care about the line cards and the features. We don't care about performance and slots and stuff, so it's just the Nexus 7K with the same supervisor as I would expect in any of the other chassis. So we will probably have 2 of those chassis. Now the beauty of the Nexus 7000 is, as you may or may not know, is we can create virtual device contexts. I will not go in depth on virtual device contexts, but I just want to let you know what it is or what it can do in the basis, because this is going to be used in the lab and you really need to know how it will work and how you can change topologies and stuff. In this Nexus 7000 supervisor, we are running NXOS. We are running 2 images. So we are running the kickstart image and we are running the system image. The kickstart image is nothing else than the kernel, just a Linux kernel to run the operating system. Then the system image is the actual iOS-like operating system, so the Cisco operating system. Now within that system, I can create virtual containers to run different processes and interfaces in. So when I boot the switch up, I have VDC1 in my SUP 1, so imagine that this is a SUP 1. And in that SUP 1 I can start virtualizing different VDCs. VDC1 is my default VDC. What do I run in VDCs? Well, for example, VLANs, or routing protocols like OSPF or HSRP, all kinds of protocols, and VLANs. And I have ports. By default, all my ports are in VDC1. Now the Nexus 7000, which is the only Nexus that can do this, no other switch in the Nexus line can do this, so it's really purely based on the Nexus 7K. The Nexus 7K can create multiple of these containers. Depending on the supervisor combination you have and licensing, I can create usually up to 4. So in the lab we have up to 4 VDCs. That includes VDC1, which is the default VDC. So I have VDC 2, 3 and 4. Now in those VDCs I can run separately, I can run another set of 4000 VLANs because I allow other interfaces here. So I say ports 1 through 8 are in VDC 1 and ports 9 through 16 are in VDC 2. So this means that I need to physically allocate interfaces into those virtual switches. These are virtual switches. Each have their own configuration file and each has their own set of interfaces. Meaning, because I have my full set of interfaces, I also have the full set of VLANs available. So also VLAN, OSPF, and I'm running VRRP here. All these processes have nothing to do with the processes in VDC1. So all the VDCs run independently of each other for all of their features. So I can create up to 4 of these VDCs. Now, as already mentioned, there is one exception for the creation of VDCs, and that is the FCOE traffic. The Nexus 7000 supports FCOE, but it only supports FCOE in a separate VDC. So there needs to be a VDC created just for FCOE and nothing else. That VDC will not run VLANs, that VDC will not run spanning tree, that VDC will not run OSPF, it will only run FCOE. This can be a normal VDC or a storage VDC. This is called a storage VDC, so that storage VDC does the FCOE traffic. So that is a special VDC, but it consumes one of the VDC numbers. So I can create 4. If I make a VDC for FCOE, I only have 3 remaining. So that is my VDC setup. What can I do with this? Well, because I'm allocating different interfaces to different VDCs, so there's a lot more to this and how to configure this and stuff, but I'll just go through the concept here, and if you want to know more about VDCs themselves, then visit one of our boot camps, either online or on-site. So in this VDC configuration, we determine which interfaces belong to which VDC. This means that I can create multiple topologies based on this. So there's no way of doing internal connections here. All the connections on this box are done on the outside. What this means is that there is no magic between the different VDCs on the OS level. The only connection I can do between VDC1 and VDC2 is really taking one of the interfaces and connecting that back on the outside. So making a hairpin back in the box. And with that hairpin, I enable the processing of traffic from different VDCs. So that is VDC. Why do we want to use this in the lab? Well, this means that we now can create, with 2 chassis, we can create 8 switches instead of just 2. So this makes the topology much more interesting. So if we start building a list of equipment, we have 2 Nexus 7K chassis, which means that we can make 8 switches. 8 Nexus 7K. So this is going to be an interesting setup. On the Nexus 7000 we can do everything like OTV, fabric path, VPC, spanning tree, routing, HSRP, everything. Now, going back to our list. So we talked about the Nexus 7K. We also have 2 or 4 MDS 9222Is. A little bit depending on the topology that they want. So you can do like 2 or 4 MDSs. What else do we have? In our Nexus 7K, we have 2 10 gig modules. These are M1 and F1 modules. Both are very, very different in the features that they support. So we have an M1 and an F1 card, and both are running totally different features. So the M1 is really based for routing and things like OTV, And the F1 card is for things like fabric path, in short, because there are more exceptions, fabric path and FCOE. Those are the biggest differences between the cards. So we are running 2 of those cards. And we can assign cards from interfaces from both cards to the same VDC. So we can mix the different modules in the same VDC. Next one is the Nexus 5548. So a very specific module of switch or model of switch. So this means that we can do and assume that it has unified ports. So we have, let's say, 2 or 4 Nexus 5548 UPs. And if you're lucky, they have that uplink module installed. Why are you lucky then? Because then you can easily migrate from Ethernet to Fiber Channel, remember? Because the switch, I need to reboot it to migrate to Fiber Channel, and the uplink module, I need to just reset the module. So if you're lucky, they will have that uplink module in there, so you just need to reset the module to get your Ethernet ports back to Fiber Channel. So a couple of those switches, 2 or 4. Then we have some Nexus 2232s. And of course this means, so let's say 2 or 4, because it doesn't specify it now. 2 or 4 2232s. These are FCOE capable 10 gig faxes. So this fabric extender, it's not a switch, it's a fabric extender. This fabric extender has 10 gig ports, client ports, and it runs Fiber Channel over Ethernet. So this means I can do Fiber Channel over Ethernet on a fax to my Nexus 5K. So that makes it interesting topology. I did a V lecture on this 2 weeks ago, running enhanced virtual port channeling and running FCOE across it. It takes about 2.5 hours to go through it, but it's a very interesting one. So those are the fabric extenders that we are running. MDS we already talked about. We have a Nexus 1000V. Well, that's okay. So we have a Nexus 1000V that's running in our VMware environment. Most importantly about this Nexus 1000V, I have no access to the VMware products. So there is no access to the VMware products. So I cannot access vCenter. I cannot access the ESX hosts. I cannot do anything. So what this means is because I cannot access VMware, I do not do an installation of this. The CCIE is always, of course, about an installation test, configuring from scratch. The Nexus 1000V will probably not be from scratch because installation technically does not require integration with vCenter if you are specified with all the details and you run the installer application. But no, usually it's subject to so many flaws and subject to so many errors that can occur that I don't see them doing that. Next, we have some UCS C200 series with the VIC card. And the VIC card means the Palo card for the C series. So the C series are our rack servers. So we have, let's say, 2, 3, 4 of these C200 servers with the VIC card, so the Palo card. They can do 2 things with this. They can connect the C200 server to the UCS system. So just besides having a blade chassis, having the rack server connected to my Fabric Interconnect. But that will not change anything about the configuration. It's just the connection that you need to know that the Fabric extender works and stuff. All the rest, it's just configure a server port and the rack server gets discovered and you can assign service profiles to it. So technically, there's not so much difference in configuring a blade versus configuring a rack server on the Fabric Interconnect. It's technically the same thing. It's just connection-wise, you need to know what you're doing. It's just enabling the right port and then you're done. So again, I do not see them doing this because we can do a lot more interesting stuff with the blades. Then these servers will also be used as fiber channel over Ethernet hosts, meaning I will see some C200 series being connected to my faxes, for example. I will make a diagram after this, but being connected, so the C200 series connected to my faxes. What is very important here is that I have no access to the CIMC. So these C200 servers that are connected for a fiber channel over Ethernet, these are just there to test things, to test fiber channel over Ethernet, for example. So there's no access to the SIMC on the C200s. SIMC is our HTTP GUI on the C-series servers that we can use to manage the VIC card, for example, or manage the BIOS and stuff. And again, they could do that connecting it to the FI. Technically, there's not much difference in connecting it to the FI, connecting a rack server or a blade server to the FI. Configuration-wise, it's exactly the same thing. So more on the C-series server later when we start drawing the topology. What else do we have? We have our 6248 fabric interconnects. So 6248 FIs, meaning we can do unified ports. And we can do all kinds of more recent features like we cannot do on the 6020. But the 6248 is going to be my most recent version of fabric interconnect, so we can do unified ports. That's the main difference. And hopefully, again, they installed that unified port uplink module that's called a gem. If they install that gem, then you do not need to reboot the fabric interconnect to do the conversion from Ethernet to fiber channel. And you can just click OK, it will reset the module, and you will have fiber channel ports. So that is the most beneficial use of this fabric interconnect. So hopefully they did that. Now they do not specify the fabric extenders here, so the I/O modules. But you can assume, because they are running more recent hardware, that they are running either 2204 or 2208 I/O modules. So that means I can do port channeling towards the fabric interconnect. Remember, going from my I/O module towards the fabric interconnect, we can do a port channel just like we can on the fabric extenders on the Nexus 2K. That is the most important change for the 2204 and the 2208 versus the 2100 series. So support for port channeling is there, the most interesting one. And it does improve scalability and amount of links on the backplane towards the blades, but for the CCRI Data Center Lab, that's not going to be an issue. But remember, we can support port channeling here, and I need to enable that. So be very careful when you read your questions, what they tell you how the connectivity between the FI and the I/O modules should look. So the combination of the 2204 FX and the VIC-1240 means I can do multiple VCON groups in the same half-width blade. So then on to the blades. We have B200 series blades. If we have B200 series, that means we only have half-width blades. So no full-width blade, only half-width blade. So that is another example, so B200. And this can be an M2 or an M3, depending on the rack that you're in. The biggest difference here is that the B200 M2 does not support the VIC-1240, and that the M3 supports the VIC-1240. So this is going to run the normal Palo card, and this is going to run the VIC-1240. Now technically, in terms of questioning, if they want to keep the questioning correct for every rack, right? So the M3s are only in the newer racks that they only recently opened. So there's both in Brussels and in the US, they installed new racks of hardware to increase the capacity that they can do to the amount of seats that they can do per day. And that means that they are running M3 blades in the newer racks. They will run a VIC-1240. So because the M2 is running the older Palo card, there's only so much things that I can do. I only have 10 gig left, 10 gig right, right? No VCON grouping there. On the M3 blade, technically I can do that, but because I'm also running Palo cards, I cannot do that extra questioning there, because then on some racks it wouldn't be allowed. Of course, they can upgrade to M3 blades in the other racks, and then they can start asking you about the VCon groups. So be aware that that might be possible, because half of the racks already has the card installed, the other half might get upgraded in the near future. Of course, nobody knows. We have a comment, the M2 doesn't support the VIC-1240, so it needs to be the M81KR. Correct. I said it, no VIC-1240 here. But this is indeed the older Palo card. So just the M81KR, correct. The M2s are the M81KRs, on the M3s you will have the VIC-1240. And again, they might upgrade them to the newer blades in the near future, and then upgrade the tasks to some card that supports the VIC-1240. Because technically here, there's nothing that limits them. It says Palo mezzanine card. Now, a VIC-1240 is also considered a Palo card. Technically, it's another code name, but it is still the same technology as the Palo card. And lastly, we also have Menlo cards. And then they specifically specify an Emulex card. So along with that blade, we have both Palo cards, and we also have a blade running a Menlo card. So you might have 2, 3, or 4 blades. Then you will probably see 1 or 2 of them are running Menlo cards. And of course, know the differences. Menlo card means no support for failover and no support for multiple VNICs and multiple VHBAs. So only 2 VNICs, 2 VHBAs, and no failover checkbox checked. So be prepared of the changes between the Palo and the Menlo card, because you will be configuring both. Then the ACE, the load balancer appliance, this is going to be an appliance. It's not going to be a virtual, it's not going to be a module in the 6500. It's going to be an appliance. And you probably are running a highly redundant or a high redundant version. So we have the ACE 4710. We probably have that twice. So of course the fabric interconnect, we have that twice. The B200, we have about 4 blades, I think, in the chassis. So just 1 chassis. And then we have 2 ACE appliances. The 2 ACE appliances can run in HA mode. So know a little bit about the ACE as well. I'm not going to answer the questions if it is on the lab or not, because they changed the blueprint. So I need to know more from my contact within Cisco about that. So I hope I can give you that answer tomorrow. So the ACE and the final topic are JBOTs. JBOTs are just fiber channel disk arrays. Nothing special. These are just arrays that connect with fiber channel to the MDS switches or to your Nexus 5K switches with native fiber channel, and they will advertise some disks in the network. And one of those disks will have ESX installed, or maybe multiple disks will have ESX installed, depending on how you can configure it. You can boot multiple blades from the same ESX host. Now, so we discussed the hardware. A more recent change to the blueprint is that they changed the software versions. So let me get over the software versions first. These are, except for the Nexus 5K, the newest versions that you can run on all the systems. Why? Because they have an X. 5.x, 4.x, 5.x, 2.x. The 4.x and the 1000V doesn't mean a thing, because the Nexus 1000V is at 4.1 since its initial release. The real version number is way farther in the version numbering. So I wonder why they specify this strange version. It can be any version of the 1000V, although that is not really a problem, because they all basically run the same thing. They are updating some features. The version that they're running in lab is a very recent one probably, but yeah, that's okay, right? It's not changing a lot of things. So the NX was 5.x, the most recent one is 6.x, 6.0 right now. So they are running some 5 version. Not a lot of changes are happening in that 5 code train, so be prepared for that. Now 6.x is a dangerous one. So 6.0 was the initial stated Xaver version. Let me grab a slide with that. This is the initial version of the software blueprint. So it stated exactly which version we were running. Again, for the Nexus 1000 it didn't matter because that version means everyone. But for the Nexus 7000 they are running 6.02. And 6.02 is completely different from 6.2. Especially in Fabric Path, 6.2 supports the things like DFA and all kinds of new features in Fabric Path like Anycast HRP. So a lot of new features in the Fabric Path portion of that OS. Again, they will not use that in the lab. They will still run 6.0, although they specified 6.x. They did that 6.x to be more flexible in the terms of upgrades, they say. Although I think it's pretty strange because you can just use the other one, right? Just use what we are all used to. So just use 6.0x, for example, so you can upgrade minor versions. But they chose to do the 6.x so they can be very flexible. Although 6.2, for example, DFA means introducing a new blueprint. It's a new feature on the blueprint, so that would take the 6-month period that they take before applying changes. And then Nexus 5000, so actually the only one that is changed currently that we know of is the UCS software version. That's going to run 2.05 to support Java and to Java 7 and to support the B200 M3 blades. Because this version doesn't support the M3 blades. We see which Java for the ACE, and we also see that we have access to the DCNM, both LAN and SAN. DCNM is there for your convenience. They will probably not ask you to configure OTV through DCNM. You can do that. There's a wizard for configuring OTV. I don't see them doing that. DCNM is there for your convenience. If you think you find it easier to configure OTV, for example, in DCNM, go ahead and do it. So the Data Center Network Manager will be available to you. A little bit. So Data Center virtualization fundamentals. And then NXOS and Nexus switching, it's called, I think. Second edition. We have that new end-to-end QoS book. Which is released very, very soon, or is just released. And then finally we have the storage networking fundamentals. It's an older book, but it's still an okay book about the fiber channel protocols, fundamentals. So 4 great books. And if you want to go really deep, fiber channel bench reference guide. So 5 great books. I would highly recommend the ones above. They will tell you a lot, and this is probably what you want to learn for the written exam, along with some basic knowledge about the ACE. That is covered in this book, but read configuration guides. And of course, aside from books, read the configuration guides. They are pretty good reads, actually. Oh, and let's not forget the MDS cookbook. There was a PDF called the MDS Cookbook on the Cisco website. It's still there. It is based on a very old SAN OS release, 3.1, but it is still an invaluable resource because it will take a lot of example configurations on the MDS and show exactly what they do. But at least if you want to read one or two books, read one of the two top ones. They are excellent. And for UCS, there's not a real good book actually. So yeah, it comes down to watching this video. There was a UCS book, but that hasn't been updated since the first version, and that is based in 2010, I think. So the hardware covered there and the features is 1.x. It's not covering the 2.x features. And there are plans to do a UCS book, I think. Let me see if that already is compute. So there is a book in 2010, but that only covers UCS 1.3, I think. Here in 2009, the Project California book. So there's nothing about the UCS. Let's see if it covers. So this book covers Xeon things and how the Intel architecture is and stuff. So it's a strange book. And again, it covers the 6100 fabric and 2100 fabric extender. So old stuff. All right. So that's about books. Can I please Google for the MDS Cookbook? It should just be a link on the Cisco website. Here, just go into the configuration guides for the MDS, and then down here on the MDS 3.1 release, we have the MDS 9000 Family Cookbook. Let me increase that font a bit. This MDS 9000 Family Cookbook, it's a PDF. And that, like I said, it's an older release, but it's written very easily and it's written like a book. So you can read through it like a book and not compared to the configuration guides. They are very technical, just focused on certain features. And this is not very interesting. But let's go down here using device manager here. How does upgrading firmware on the MDS? Downgrading firmware. How does it work with the GUI? What kind of ports do you need to connect? But also more interesting things like how does creating a collection in Performance Manager. Performance Manager is a tool in DCNM. It looks a little bit different right now, but you get the idea. Security features, user rules. This is a good book. So that is about books. We discussed the software versions. And we discussed hardware. Okay. So what about topology? Topology for the UCS Lab, for the CCIE Data Center Lab. What you will see is because we have 2 Nexus 7Ks, we can make 8 switches. So what you will see is that the test is going to be designed in 5 major sections right now. It used to be 4, now it's 5. We have the NXOS section, so the networking part. We have the storage section. We have the compute section. We have the virtualization section. And we have the application section. Application networking section. Or ANS. So these 5 sections are in there. Now on that new blueprint, as we discussed yesterday, Let's log into this. And these are the percentage values in how much points it will get assigned. So NXOS is 30%, so 30 points. Storage is 20 points. Compute is also 20 points, 30 points, sorry. Virtualization 10 and application networking 10. In total, that comes down to 100%. So I'm not sure if these are the actual percentages in lab points. It does come close. I always thought that this was a little bit higher, somewhere around 40, 35 to 40, and this was 20 to 25. The grade is always 100 points, yes. The CCIE test is always about getting 100 points. So you will get 100 points in total. You need to get 80 or more. So 80 points is enough or more. But not 97, it needs to be 80 or more. When looking at a task, you will see a task like 1.1. This task will say configure XYZ, blah, blah, blah. Under that, there will be some bullet points specifying details about that task. All of these combined will result in some configuration. In the bottom of the task, it will say 3 points, or 2 points, or 6 points, or 1 point. And all of these tasks combined will get to a total of 100 points. If you use our mock labs in the workbook, you will see that every mock lab totals to 100%. Because it totals to 100%, we also divide the points between the sections compared to how it will be in the lab. Again, so you will see in the networking section, you will be configuring about 30 points. And then don't get surprised for, let's say, task 1, configure VLANs, configure 20 VLANs in the network, 1 point. That's going to be 20 minutes or 10 minutes of typing for just 1 point. That's a lot of work, right? So some tasks give you more points than you would expect, and some tasks will give you less points than you would expect. So you step into the lab, you only get 1 point, and you're already 20 minutes down the road. Now, the NXOS section is separated in two different sections again. So you will see that the architecture of the CCIE data center test is based on data center 1 and data center 2 architectures. So we have two different data centers that we connect to each other. So data center 1, how the points are divided, it can be equal, it can be unequal. It depends on what features you are configuring in one data center. I will not configure the same data centers, right? I will not configure fabric path left and fabric path right, then do VPCs down to some hosts. They will not be equal data centers. They will be different. So one will be running fabric path, the other will run VPCs, for example. So there will be some difference there. So we have that DC1, DC2 topology. And now we can start building our topology drawing. Again, because we have 8 switches only on the Nexus 7K, we can do some interesting things. So you will see, let's say, 2 core switches, then a storage VDC, and maybe an OTV VDC. OTV also usually requires a different VDC. It doesn't require, but there is a good option that you need a different VDC to run OTV across. So we'll have the same here. So this is already my 8 switches. That's a lot of devices already configuring. The connections can be anything. For OTV, we always require 2. We do OTV on a stick, so we need a layer 2 and a layer 3 link. We have a fiber channel over Ethernet connection here. or maybe down towards a server here. So UCSC server 1, UCSC server 2 will be connected with FCOE. This cannot be existing. So I have my Nexus 7K1, Nexus 7K2, Nexus 7K1, all kinds of naming conventions that you can imagine. And then in between, we have a split for data center 1 and data center 2. What do we run in between? We have what's called a backbone device. Same as in the CCIE RNS, you have a number of backbone routers. In the CCIE data center test, we have also a backbone router. And I say a router, it can be a switch, but it's technically more interesting to do a router, because then I can do OTV across that network. And you can technically see the C-series servers also as a backbone device, right? Because you cannot access it. This will be a 6500 switch with 10 gig modules. And they connect to your Nexus 7Ks, maybe with 1 link or 2 links, depending on your setup. And on this backbone router, you can find all kinds of protocols. You can find ERGRP, you can find OSPF, you can find PIM to do multicast routing for OTV, remember? Maybe we need to do PIM auto IP. Features like that. So be prepared to do some routing features on the backbone. And you will be setting up a layer 3 network between your data centers across the backbone router. Now, you will not get access to the 6500 router, of course. It's a backbone device, and you never have access to backbone devices. You can see that you can do show CDP neighbors. You can ping the interfaces here. So I can just issue a ping for this interface, see if it works. And IP addressing will be told to you, of course. It will be given to you. Now my Nexus 7Ks are interconnected in all kinds of ways, maybe like that. The storage VDC is a bit separate. Why? Because I cannot run FCOE connections between the storage VDC and another VDC, so it may be a little bit separately. And below here I can run, let's say, some Nexus 5Ks. And in between here, I can run all kinds of topologies. So I can run VPCs here, I can run fabric path here, and do all kinds of stuff. And on my Nexus 5Ks, I have a fabric extender, the Nexus 2232. Of course, I can also do VPCs there and do enhanced VPCs. And I might have C-Series Server 3 connected here with FCOE. And then my native fiber channel connection from the N5K might go with FCOE, might go to the Nexus 5K, for example. These kinds of topologies are the ones that you can think about. So my Nexus 5K will probably be connected to the storage VDC, and I need to make sure that server C1 can talk to server C3, for example. Or this server is dual connected to both the storage VDC and the Nexus 5K. One side does fabric path and the other side does VPC, yeah, for example. So I run a full VPC network here, so here and here also, or maybe a back-to-back VPC here. And then below here I have another set of 5Ks. And then below here VPC or FIs, fabric interconnects. Then of course I make some VPCs here as well between the 5Ks and the fabric interconnects. And then these links can be fabric path links. So I do fabric path on data center 2 and I do VPC on data center 1. These kinds of topologies you need to think about. And I need to maybe transport some VLANs across these clouds to make sure that a server here can access a blade over here, and that runs across an OTV connection. or VPC Plus, yes. I'm running VPC Plus here, right? I'm doing this. VPC is towards my Fabric interconnects. Run Fabric path in the core. That means VPC Plus. And here I'm doing Enhanced VPC. So this is Enhanced VPC. This is VPC Plus. All kinds of fun stuff. And of course we have our rack server or our blade servers. Maybe, so the B series, B200s, maybe even a C series server here, although I highly doubt that. So I can have a C200 server also connected here, but that's not technically, I do not see them doing that. They are usually using the servers just to test stuff. And then finally, what are we missing? We are missing the MDSs. So final thing is that we might have some MDS switches here and here. That MDS switch may be connected via fiber channel to the 5K, and then the 5K is then connected to the storage VDC. Same here. They are connected together. And across here, I'm doing IP links. And maybe I'm doing an IP link here to my 5K. So an IP and a fiber channel link. So here on all these MDSs, I may have 2 MDSs or maybe I have 4 MDSs. With all those MDSs, what I can do here is I can drag fiber channel connections to my 5K and allow all the fiber channel connections here. And of course I have the JBOD here. JBOD. Connected with fiber channel to the MDSs, for example. So this is going to be huge topology, right? Look at all the equipment that I have. I may have drawn a little bit more equipment than you will see, but this is technically possible. To do fiber channel connections here, to do storage VDC, server connections here, running native fiber channel between the MDSs. Here I'm running IP connections to the other data center, so it means that I'm doing FCIP tunnels here. Maybe I can get a question that I need to boot from SAN on a JBOD, which is in the other data center. So running across an FCIP connection, accessing that disk here. There are all kinds of different things. The MDSs may be connected via an IP connection to the 5K, meaning I can do iSCSI. Maybe I want this server to do iSCSI boot towards the MDS. So a lot of things. What about the ACEs? Sorry, I forgot them. You will see them something like this. So ACE being connected to either the 7K or the 5K, and then here another ACE also connected to the 7K. So quite a lot of architecture, right? Quite a lot of manageable devices. So how many management points do we have here? Well, let's count them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 management points. So 19 different devices here in the network that we need to do something with. That's a lot of devices. And of course, like I said, I may have drawn a little bit extra equipment here. So you might see that dropping down to 14 or 15 different devices. Still, that's a lot of devices to manage. When you walk into the lab, the proctor assigns you to a certain desk. On that desk, there will be a paper telling you the username and password that you need to use to log in. On that desk, there's also some stationery, some scrap paper that you can use with your name on it and your CCO number. So, or some else number, some CCIE number. It's not the CCIE number, but some else number. So that paper is for you only. And there are a bunch of pens and pencils and stuff. So you log into the system, and it logs you into a Windows system with only one button. Or it might do two things actually. So you might end up in a system that you need to further RDP into another system, or you are already on the rack. So if you are in Brussels, for example, that rack is local. If I'm on a remote rack, I RDP first to a rack to a computer which is in that rack itself. So that's just a shortcut. You double click it, it logs in automatically. You end up in a desktop where you have a couple buttons. So on the paper, it says username and password. Those are your login credentials for the Windows machine. So you log into the PC. That username and password are case sensitive, of course, so be very careful. I had trouble reading my password correctly, so I asked the proctor and they logged me in. And then you get on a desktop, so either with RDP or just local desktop. And on a desktop you have two buttons, I think. So there is a button called Internet Explorer. If you open Internet Explorer, it will show up the Cisco documentation page. Which page? This page. If you go to support all products, this is the page that you will see when you boot up Internet Explorer. So this is going to be your home page of Internet Explorer. And beware, it's going to be slow. Every page you open in IE is going to take seconds to load. There is some kind of ancient proxy server behind this connection because it takes 5, 6, 7 seconds to load a page. So every time you click on a link, wait 6, 7 seconds. That doesn't speed up your browsing of documentation, right? That's irritating. So Internet Explorer. The other connection, the other topic is, I think it's called drawing or topology or something. I'm not very sure actually. So there's this other button that says drawing or topology. That will open up a web browser showing you this. You will see this, not my ugly drawing, but a nice drawing from Cisco showing all the different components in the system and how they are cabled with the correct port numbers. So you will see exactly what the port numbers are, what the device names are, and all kinds of stuff. What you can do then, if you opened up this window, is I can click on one of these devices, so just tap or double click on the device or single click on the devices, and that will fire up PuTTY. So in that drawing, click on device, and that will fire up PuTTY. No secure CRT, only PuTTY. With default settings, and you can change the layout or the text or the font or anything if you like it. So it's just open up PuTTY Windows and you will see these 8 switches being configured, because you also need to know the cabling between them. By the way, if you run into a physical error in the lab, you see if I do show CDP neighbors, I do not see from N7K1, I do not see N7K2, but I see something else. Go to the proctor and say, hey, on this connection, it says I need to have that switch. The lab task tells me exactly the same thing. So first check the task, then check the diagram. The diagram is there to help you. So the diagram may contain errors. The task should be good. That's always the guide that I use. So my lab task should be the correct questioning. The diagram is only a tool. The task is what I get the points from, right? So if the lab task tells you configure port 3 and the diagram says 4, then you're going to configure port 3, because probably port 3 is going to be the correct one, and they changed some things in the diagram. I don't say that this is really the case. So depending on what you see, I would believe the task earlier than the diagram. So opening up PuTTY windows. Now the problem is, I have 15 devices. I'm not going to open up 15 PuTTY windows. I only have a single 22 or 24 inch screen. And I'm not going to be able to do both the diagram, the lab task, and all my PuTTY windows in the same window. Because everything will be digital. There will be no paperwork. Right, so next thing. About the tasks, I'm going to come to that point. So the PuTTY window opens up. The Nexus 7K, I'm opening that through SSH. All the other equipment, so the Nexus 7K is SSH. Why? Because I only have one console port on the 7K, right? So if I access the Nexus 7K on a console port, I will always end up in the same VDC. If I SSH, I can connect to each VDC separately. Unfortunately, we do not have two monitors now. They are planning to do that, to create multi-monitor setups. When that's going to be done, nobody knows. So we've had words from proctors that said that they are testing with a dual monitor setup. When that's going to be out, nobody knows. Like I said, the Nexus 7K, I'm going to approach that through SSH. Then all the other equipment is going to be console. So everything else. Alright, so console for all the others. The console is running at 9600 bits a second. Why am I telling that? On the Nexus platform, if I am accessing the system via console, I cannot do debugging. I can only do debugging if my console speed is set to 30K. So I need to set at least a console speed of 30K, and I cannot do that at 9600 bits a second. So no debugging on the devices that you are doing, on the other devices that you're accessing via console. Alright, so that's how I access the equipment. The PuTTY window, by the way, the title of the PuTTY window will be the host name of the device. So that's where you can recognize in your menu bar, in the start menu bar, you can recognize which device you're on. And be very careful. Be very careful which device you are configuring, because the host names are very much alike. It's not going to be R1, R2, R3 like in the RNS test. No, it will be something like Nexus 7K Data Center 1-1. Something like that. So you will need to look closer to what exactly are you accessing from. And because the start menu bar is too small, you will have a lot of windows there where you do not see the full host name in them, for example. So a lot of things going on in terms of screen real estate that you have. Now, how do I see the tasks? I'm now connected to my equipment, and I would advise you to only open up the PuTTY windows for the devices that you are configuring. So if I'm configuring the VPC task, that's going to run between 7K1 to Nexus 5K1 and 2, only open up those 4 PuTTY windows. Because that will limit your scope with there, and of course you can easily switch between them, right? Because every time you just click on the device, it will open up the PuTTY window and you can work again. So I would always recommend only open up the windows that you really need to prevent the confusion that you are configuring things on the wrong device. So open up only the windows that you are using. Then next, the tasks. So above here, so I have my full topology drawing. I have that whole window. Where do I find my tasks? They will be on top of that window, so on top of the drawing. So if I have my drawing, here I will have a menu bar that has buttons or some JavaScript menu. They got very creative with HTML and JavaScript. there will be multiple buttons. So I can see the full lab. So when I click on the full lab button, a pop-up window comes up, and that will show you all the text that I have available. So every page of text that I have available, all the tasks, all going to be above each other. I personally like to use the section-based approach. So there will be another button called section, or task, or section-based. Either way, this will open up a menu where I can select Nexus Data Center 1, Nexus Data Center 2, storage, compute, and so on and so on. So I can select then, if I select Nexus Data Center 1, it will only show me the tasks for Nexus Data Center 1. I liked to use that because that limits your amount of text that you have in the window. Besides that, you will also have an introduction. That is, let's say, 2 pages of text, just clear text that you need to read through. That they're going to tell you what you are configuring. It basically says you are configuring a dual data center setup. You can or cannot use static routes. You can or cannot do this. Points will only be given for full sections and not per point. All kinds of stuff. So you please read the introduction, because they will also tell you some passwords. They will tell you in the introduction, they will tell you the device admin passwords. And they're not all the same. So for example, for DCNM, you might need to use a different username password than you are used to using it on all the other devices. So read through the introduction, because it will give you valuable information like what you are configuring, how the network looks like, and it will tell you exactly what the passwords are. And some IP addressing information. Now, alongside these sections, there is one more section, and they call that, I think, page 2 or something. At least there is another button, and I think it says page 2 or something. And on that page, I get a table of all the settings that I might need to use. So for example, for the UCS pools, it will have a small table stating exactly what kind of pool, how it should be named, with a size of addresses, something like that. Or it will show you worldwide port names to boot from SAN. Or it will show you, I don't know, VLANs, a table with all the VLANs that are in there. A table with MAC addresses that you need to configure for port security. So everything that you can put in tables, they have that in a separate document. So if they tell you in the lab task, they tell you configure UCS pools according to to page 2, then go to page 2, find the task, and see what it says. So that will be a separate document. By the way, for boot from SAN, if you're getting something like that, or at least for the JBots actually, it's not related to boot from SAN, it's going to be related to zoning and the JBot access. Because we are running hardware-based racks or storage arrays, we will have different worldwide port names per rack. That means that if you're doing the lab in Brussels, you will use a different worldwide port name than when you're making in San Jose or in RTP. So pay attention very specifically to this worldwide port name, and that will match to a location and the rack that you're using in that location. So it should state that on the monitor which rack number you're on, and then the page 2 one will show the worldwide port name for Brussels rack 2, for example. Be very aware at which rack you're on. Of course, if you enable the port towards the JBot, you will see that worldwide port name coming online. But there are people who had issues with misconfiguring worldwide port names because they misconfigured based on the rack number. But if you're clever enough, you would do a show floggy database or show FCNS database and just look at the worldwide port names that are logging in. One of them should match with the one on the paper. You are free to use any kind of aliasing that you want to do. So you can do in XOS, you can do CLI aliases. For example, I usually make one for WR to use write to save my configuration. Otherwise, I need to do copy run start and stuff. Again, racks do not have UPSs. If there is a power outage, you lose your config. If you did not save it, of course. So save frequently. I usually take that moment to relax a little bit. So just type in WR on all my devices and see where we're going. And then I'll start reading the next task, for example. Now there are some people that want to take the lab on a very mathematicical basis. So they say, I have 8 minutes per point, and then if I have that kind of minutes, I need those amounts of points. And I usually just sit down and make the lab. Problem with the UCS or the CCIE data center lab is that because the scope is so wide, everything builds on top of each other, right? If my Nexus 7K is not properly configured, my C-Series server might not come online. So everything cascades on top of each other. Some people like to save the startup configuration as they approach the lab, that if they mess up, they can revert back to the startup config, so to the original config. So you're free to do that. When you step into the lab, do a copy run and then save a temporary file. You're definitely free to use that. And then if you mess up your configuration, you want to revert back to the initial configuration, then that is good. I would never do a write erase and then reload. Always go back to the original starter configuration from Cisco. And of course, when you leave the lab, delete that file. Never leave any traces behind of you except for your config. They tell you, like with aliases and stuff, they say you can let the aliases on the, you can leave them on the devices. I usually delete them. I just want to be sure that I do not screw up with maybe commands that the verification script is using. So if my aliases maybe at some point interact with the grading script, I would just like to remove them, right? That is the whole point of the data center lab. You need to cascade everything on top of each other. If I have VLAN 100 in data center 1 and VLAN 100 in data center 2, probably my fabric path points and my OTV points are lost if I misconfigure the VLAN. So that's a lot of points by just misconfiguring a VLAN on one of the links, for example. So you can get into a lot of situations with this. So be sure that every single task is done properly. And I would just do them in order. Start with data center 1, go to data center 2, go to storage, go to UCS, and then do the rest. So most people start with UCS, I think at 1, 2 p.m., something like that. You can finish this lab in 5 hours, 5, 6 hours. You can finish the lab if you are fast, if you know if you know your stuff. So you will have time enough to verify everything. The questioning will be more straightforward than the RNS. I will not say fully straightforward, but it will not be as complex as the RNS questioning. In RNS, you will have very cryptical questioning of questions. In the data center, they are more straightforward. Like I said, you will have a task saying virtual port channel. Well, that usually means that I will be configuring virtual port channel, and they will give you configure Ethernet 1/5 as the peer link. So you know exactly what the peer link is. So it's more straightforward. Of course, you need to work on speed. Speed is always one of the biggest issues in the UCS lab. So work on the speed. It is always important to know your commands very fast. If you need to look for everything in the documentation, you will not pass. So there is enough time, but there is only enough time if you know your stuff, if you are fast on the CLI. You can use Notepad, Calculator, and Internet Explorer. Those are the 3 apps that you have available on the Windows machine. So Notepad is definitely available, as is Calculator if you want to if you calculate something. So yes, use that if you want to copy and paste things, especially for OTV, for example. It's a good example to copy and paste from one site to the other. That's usually a good one. Oh, and I missed how you approach. So this, what I currently talked about is just approaching the CLI items, right? We did not talk about the GUIs. On my desktop, along with the IE button, there's also another button saying to connect to an RDP session. If I connect to that RDP session, I will get a new desktop. And in that desktop, I will have access to UCS Manager, and I will have access to the Data Center Network Manager. What I didn't try, there is also a PuTTY executable here. It might be possible to just go in here and SSH towards the management IP addresses. I didn't try that, but you might find an SSH connection is possible to other devices based on the PuTTY executable on that RDP session. So like I said, this is done to access the GUI. So here the correct Java version is installed. So I open up the RDP, a new desktop opens with a couple icons, one of which is UCS Manager, one of which is Data Center Network Manager. And of course the LAN and the SAN part. And nothing else. That's going to be there. So again, the cascading is the biggest issue. Do the lab in order. There's not anything that you can skip actually. Everything you need, everything is infrastructure related. If I'm configuring VPCs, I need to allow some VLANs. If I'm configuring fiber channel features or FCIP, that's probably going to be needed to allow a server to access a disk in the other data center. So there's a lot of traffic going on. There's not much traffic going on, but there will be servers accessing storage in your lab. So for example, the blades will boot from SAN. And that's going to cause some traffic in your data center. So there will be some traffic on the links. Not that much, but there will be traffic. So there's a lot of things going on there. And everything builds on top of each other. About the Nexus 1000V, by the way, I did not mention that. I will come back to that later after the break when we start talking about the Nexus 1000. That Nexus 1000 has a special place in the topology. So I will come back to this drawing when we start talking about that.